the consumable electrode, if it is consumed or if it is melted, and fill the gap in between. If it is not consumable, just if it is producing the arc and the two base metals will be melted, that time it will be non-consumable electrode. Okay, so the welding is a process of joining the two similar or dissimilar materials, two similar or dissimilar metals, not materials. If I say material, it will be a plastic or some other thing. So be very clear enough. Welding is a process of joining the two or more similar or dissimilar metals together by applying or without applying the pressure, by applying the temperature, and by using or by not using the electrode, or by simply you can say by using the consumable or non-consumable electrode. Okay, so welding is a process of providing a strong joint by joining two or more metal pieces which are similar or dissimilar by applying or without applying the pressure, and by applying the temperature, by using consumable or non-consumable electrodes. So basically there are two types of welding methods. One is a pressure welding and non-pressure welding. The pressure welding and non-pressure welding, the pressure welding is also called as plastic welding. Okay, and the difference in these are same, just a small difference you can find. The pressure welding is we are going to heat the metal, heat up the metal above it recrystallization temperature, we can say. Otherwise we are going to liquefy the metal. We are going to heat the metal beyond its melting point in case of plastic welding. In fusion welding, we are going to heat the metal well within its melting point. This is only the thing. And here in the plastic welding, we are going to heat the metal. What happens? It will be liquefied, and we are going to apply the pressure, and by allowing it to solidify at room temperature, it will become a stronger joint. The fusion welding or non-pressure welding, in this we are not going to apply the pressure. In between these two metal pieces, we are going to struck the arc. We are going to struck the arc, and the metals will be heated up, and we are going to fill this gap by using the electrodes. And the examples also have been given, you can see them. Yesterday we have discussed all these. Okay, now let me come to the electrode types, the types of electrodes which you are going to use them. Okay, the type of electrodes which you are going to use them. Basically we are going to use the two types of electrodes, as I told you just now. One is a consumable electrode and another one is a non-consumable electrode. The consumable electrode is one which will be consumed, it will be melted itself while producing the arc, and this will be filling the gap between the two metal pieces. That will be a consumable electrode. We need to have many electrodes to do the welding. The non-consumable electrode, we are not going to, the electrodes will not be consumed in this, just it will be producing the arc, develop the arc, so that the two metal pieces will be melted together and they will be joined. Okay, these are the two basic types of electrodes. One is consumable electrode and non-consumable electrode. If you come to the consumable electrode, there will be coated electrode and non-coated electrode. A coating is very, very essential. The coating is made out of a flux material. The main function of this flux material is that when the metal is heated up, when the arc is developed, the temperature will be up to around 4000 degrees centigrade. So at this particular temperature, the two metal pieces will start to melt along with the electrode. And this flux material is provided. Why? Just I will be telling you once again. When this molten pool is there, this will be a molten pool, and this molten pool, if assume that there is no flux material, we are not going to use the flux material. Okay, so that time what happens? This pool of material already it is in hot condition. We are leaving it to room temperature, we are leaving it to the atmospheric temperature to solidify down. So what happens? The contamination of the unwanted, the impurities present in the air, which will be in contact with this. And another one, the second one is that the cooling rate will be increased. The cooling rate will be increased. So due to this cooling, the rate of increase, the cooling is very faster, and the contamination of the other dust will fall into this molten pool. What happens? After solidification, the welded joint will not be so stronger. One thing is, already impurities are there and blowholes are there. The second one, we have not provided any kind of coating. As I told you in the previous class, it has to be cooled down at normal temperature. If it is forcibly cooled down, or we are going to pour the water, what happens? The solidification rate will be increased. Okay, the solidification takes place at faster rate. So due to this, the microstructure, the metallurgical structure of this metal will be changed, and it will be creating the weaker joint. So in order to provide this, a production for the molten metal to cool down slowly, to solidify slowly, a flux is coated over the electrode. While the electrode is melting, the flux also will melt, and it will be forming a cover over the molten metal, because the flux is having lower density, and it will be providing a coating over this. So directly the air will not be in contact with the metal. One thing, the impurities will not enter. The third one is that the rate of cooling will be at slower rate, so that after solidification, the solidification rate is very slow. After solidification, the metallurgical structure of the members will be very stronger as that of the base metal. This is what we are going to provide the flux over the surface. After doing the welding process, what we are going to do is, we are going to remove this flux. We are going to remove this flux. Okay, once after solidification. Okay, and this is about the welding. And another one, we are going to use the welding transformers. Step-up transformers will be used. The welding input current may be a DC current or AC current. If it is AC current, this will be, the figure is showing the AC current. If it is a DC current, in most of the cases, in very, very essential cases, wherein I want to melt down only the base metal at faster and electrode at slower rate. Okay, I want to melt more the base metal and lesser electrode. That time we are going to give the positive polarity to the base metal and negative polarity to the electrode. In some other cases, I want to melt down more electrode because the gap is very larger. I want to melt down more electrode and I want to melt lesser base metal. That time the electrode will be given a positive polarity and the negative polarity will be given to the base metal. So like that, based on the consumption, we require to have a lesser electrode consumption or more maximum electrode consumption, the DC power supply will be given. So to which you are going to give the positive polarity, that will be melting at faster rate. Okay, this is the criteria behind. Okay, and here in this arc welding, or simply we can say welding process, arc welding process. In this arc welding process, once you get the electrode near to the workpiece, the arc will be developed. Once the arc is struck, a gap between the workpiece and the electrode, a gap of around approximately 2 to 4 mm will be created. And this gap is more than enough to continuously develop the arc, so that the electrical energy is converted into heat energy. As I told you, at this particular zone, when the arc is struck, the temperature will be around 4000 degrees centigrade. Even you are going to do this welding in the rain also, within the room also, the temperature will remain same. Okay, and this particular tip temperature is more than sufficient to melt the workpiece as well as the electrode. This is what the basic principle of welding. And most possibly, while you are going to do the welding, what kind of base metal you are going to use, the similar kind of electrodes will be used in order to presume the similar or homogeneous material structure. If it is a mild steel and mild steel, a mild steel electrode will be used. If it is a cast iron, a cast iron electrode will be used, so that the metallurgical structure of the members will be homogeneous after the welding, after solidification. Okay, after solidification. And here, in some other cases, I told you 3900 degrees centigrade. In some other cases, I have written 5000 to 6000. In some other cases, 8000 degrees centigrade. All these will be based on the application, and we can even change the, or we can do the changes with the arc developed also. Okay, so minimum of around 4000 degrees centigrade will be there. Okay, in the molten pool temperature. Now, this where we are going to use this, applications. We are going to use this application for the heavy body constructions, where presses and aerostructures and shipbuilding and truss building. We are going to use some roofs on your houses, the truss building and machine component development. Okay, and some other container development, boiler developments, and